Zoom. Let's see here. Choose virtual background. Share screen. Oh, let's see here. Oh, I think I know what I can do. Let me see if this works. Share screen. Advanced. All right, let's have fun. Let's see if this works. PowerPoint file. And POE statics, Centroids. Oh, file in use. Okay. Close it. Try it again. Preparing PowerPoint. Let's see what happens. Yeah, no problem, Kyle. I'm Verizon too. We were all off the internet for a while. There was a whole East Coast dealy. All right, let's see if this happens. If not, I can just share a screen with my regular PowerPoint. Just want to see how cool I can be. Looks like I'm not that cool. Preparing PowerPoint. Try it. It's probably not going to work. All right, forget it. I'm giving it up. Giving up on it. Cancel. Okay, now how can I cancel it? Awesome. This is great. Stop share. There we go. All right. Let me do another share. Open up my PowerPoint again. All right. So go and get your notes out. We are talking about centroids and statics and all that good stuff right now. We are moving into a new topic, and it is going to be, so if we did electrical engineering before, we did mechanical engineering before that, right? Because we had simple machines, that would be mechanical engineering. Mechanical engineering would be things moving, okay? Electrical engineering, obviously with electricity. Well, structural engineering would be, structural engineering is going to be things sitting still and how much of a load can things handle and so for a bridge, stuff like that, making a building. So that's different than mechanical engineering. All right, pulling it up. Let's see where it is. Static Centroids. There we go. That's up and running. My PLTW. All right, I'm going to be doing a couple things right off of my PLTW. And again, this is off your own site. This is stuff you can get. And I'm going to Zoom, share screen, and that. That's not what I wanted. I want that. All right, I'm getting there. Statics. Okay. Everybody see my screen there, the statics?
Yes.
Thank you. All right. So I want you to see where we're at. So we are at, in POE, we have moved into, we're going to be in unit 2 now, materials and structures, okay? We're at statics. So we're statics right there, okay? We are not going to deal with career field description. I'm not making you do a book report on careers. We are going to be going and talking about statics, but let me find that screen right there. Okay, so here we go. This is not the notes. I'm showing you a quick overview of everything in statics to begin with. Then we're going to get into nitty gritty with centroids, which is a part of statics. Okay, so with statics, we have laws of force, which we will be addressing down the road. Okay, so we'll be talking about forces. And yeah, for any physics students out there, it's going to be the same stuff, learning forces just like you learned it for physics. We're going to talk about equilibriums. Okay. The idea is that an equilibrium is when two things are balanced. Okay. If you are building a bridge, you really want to have that bridge in equilibrium. If it wasn't in equilibrium, that means it would be, I don't know, accelerating up towards the sky, which wouldn't happen. Accelerating down towards the, I don't know, water or whatever you're going over. That's not good. It could be accelerating and rotating. That's not good for a bridge. So all that stuff is equilibrium. So what we're going to be doing when we're going through a lot of this stuff, and I'm going to zoom in. I'm sorry if the screen's too small. That's better. We're going to talk about, okay, are the forces equal? Are they in equilibrium? Okay, meaning the force is up, the force is down. They're equal. We're going to talk about rotational. Is the moment, because we call it moment when things rotate, we call that moment. Are the moments in equilibrium? Okay, you're going to start seeing these little symbols right here. See that? All right. Anyone taking calc would know what that is, but probably nobody else. But that little symbol is sigma, and that just means the sum. All right. Now you have probably seen it in Microsoft Excel. Okay, if anyone's had to do any learning with Microsoft Excel, there's a symbol in Excel that looks just like that. And that just means if you had like a column of numbers or a row of numbers, you could hit sum and it would add them all together. Okay, so the sum, is adding together. But there's a fancy symbol to make you look really smart. Okay, so there's all that stuff with equilibrium. Okay, we're going to talk about forces. So here's just a really, really fast breakdown of forces. So we have forces here, and we're going to go in more detail. There's moment, which is rotation. So that is the quick overview. That is a very, very fast overview. Let's do the review. Here we see. Let's see what we got here. Get started with the review. Which of these statements is true about Newton's first law of motion? Well, I didn't even go over first law of motion. I will. But the first law of motion is that objects in motion stay in motion, objects at rest stay at rest, meaning unless an outside force acts on something, it will not change its velocity. So its velocity will stay constant. Am I smart? Oh, I can't hit submit yet. All right, next one. Which of the following statements represents unbalanced force acting on an object? Well, if there are two forces, forces cause things to accelerate. So not move, they cause them to accelerate. So if two objects are pushing back and forth and one force is greater than the other force, you get acceleration. So it is going to be changing velocity. And look at that. I am smart. My mom told me I'm smart, and now I know it's true. Okay, so that was a quick overview of the stuff we're going to cover. Okay. But today we're going to be just talking about centroids. And the way I'm going to share share the centroids is through this screen right here. All right, so I'm going to do a new share, and I'm sharing PowerPoint. All right. Everybody see that? We're good to go? Yeah. I'm wondering if I wanted to do another way. I'm going to try something real quick. I'm going to stop my sharing. I'm going to do something here. Go to the slideshow settings. Sorry, I know you're not seeing what I'm doing, and I'm just talking out loud about myself. Let's see here. Slideshow. Okay. And let me do my Zoom. Share screen. Oh, and you get to have my notes down below. Isn't that awesome? Here we go. So here we go talking about centroids. Centroids are going to be very, very similar to center of mass or center of gravity. Okay. And so anyone that's taken physics, and I got a couple of you that have taken my physics class. So, I've talked about center of mass, center of gravity before. But a centroid, okay, here is our, Oh, Lordy. Try that again. I think I clicked the wrong thing. Try that again. Oh, damn. Okay, let's see if it still works. Okay, so here we go. So there is center of gravity. And see that little symbol right there, that little target symbol? That's what we could use to point to where the center of gravity is. All right, now, if you have not learned about center of gravity, center of gravity is a part of an object, okay, where the center of all of it, if I wanted to balance this meter stick, I would place it at the 50. It's 100 centimeters, and pretty easy to find the center of gravity of this meter stick because it would be right at the center, at the 50. Okay. Now, some objects might not have the same equal, and symmetrical spot to get a center of gravity. Okay. Now, here we go. So if I were to hold this first one, so obviously this one right here, oh wait, this one right there, that's an equilibrium if I'm having my finger at the middle of that dumbbell. All right. So if my finger is on the center of gravity, it's going to be balanced. It's going to be in equilibrium. If I don't have my finger on the equilibrium, it will not be balanced, and I get that. Fancy, huh? Okay. All right, now, moving on with centroids. Centroids can be found by looking at the cross section of an object. So we are going to be moving way more onto centroids than just where do you balance something. All right. So what we do is when we need to figure out, we're gonna have to do some calculation with how much load, like this, a beam like this, how much load can handle. A lot of different information that we have to do, say for being a structural engineer, but finding out the centroid and knowing the centroid of an object is actually going to be very important. Okay, so this is showing over here the cross section of that object. All righty. Okay, now different objects will have, or nice basic shapes. If it's symmetrical, it's kind of easy to find the centroid. Okay, but we'll also have equations. So what we're going to be doing is a little practice with centroids, and we will have equations to go along with it. So let's see the first. So if we have a line of symmetry like this triangle here, well, then we know the centroid would be somewhere along that line. Okay. Now that one's a little harder because if it's a square, we could figure out exactly where, but somewhere along here, and we'll have an equation, but somewhere along this line is where the centroid has to be because we have some type of symmetry. Okay. So that's the easiest one, or that's the least we can get out of it. Now, what about a square? Okay. If you have multiple lines of symmetry, then where those lines of symmetry intersect, right? So think about this square. If we have two different lines of symmetry, okay, the centroid has to be at the center of it. So we got a square and a circle. There we go. We could split. We could do it even straight down and all that. But there's our centroid. A circle, okay. Obviously, there's a million or there's infinite lines of symmetry on there. So again, wherever they intersect, that will be where your centroid is. Okay. All right. So again, and that's how you're going to mark your centroids, with that little target. All right. Now, here is a quick math review for you. You will have to be able to calculate areas. So if you have a centroid and we have to figure out if we have weird different shapes, calculating the area of a shape is going to be important. Okay, so everybody, quick review of our areas and how to calculate area. All right, pretty easy, but if we need a reminder, so a square is going to be easy, right? Area of a square is just going to be the side squared. Boom. All right. A rectangle, area is going to be base times height, right? Circle. Does anyone remember that?
Pi radius squared.
Yes, sir. Pi r squared. So pi r squared is the area of a circle. All right. Anyone that took my physics class this year would remember this. The area of a triangle is going to be what? 1/2 base times height, because see that this rectangle here, there's base times height, right? And if this triangle, especially, it's easier when you look at it like a right triangle because it's basically half of a rectangle here, but it's just going to be half the area of a rectangle. So 1/2 base times height will get you the area of a triangle. Boom. All right, now to find, here's where you're going to have some notes, and we got to look up the equation sheet at some point on PLTW site so that we start having available, because we're going to get some crazier formulas that you just want to have available. Okay, but you do want to keep these in your notes. So the centroid location, if I were given a square or a rectangle, okay, the centroid location right there would be the x value. You need an x value and a y value, right? Think about a graph. And this, here's my y. I can't do my drawing on it. I can do a drawing. Let me see if I can get my drawing going here. Annotate, and that's fine. Purple's okay with me. All right, so look, here is my here's a graph, right? Goes like that and like that. Here's my origin. I really shouldn't have done purple, should I? Let's do a different color. Let's clear it. Get another color in here. Red would be perfect. Here we go. So, and I didn't clear it. Eraser, eraser, draw. There we go. All right, so let's try that again. So here's my graph. Whoop. Oh, that went crazy. And here's my origin, right? That's that graph. So if I need to know where this centroid location is going to be, I need to know how far over x and how far up y, right? And that's going to get me my centroid location. Obviously, square is going to be the same value, but it's not even worth spending time with a square. Just treat everything rectangle, right? So here we go. Cancel the annotation. So that centroid is going to be located 1/2 the base over and 1/2 the y, or 1/2 the height up. Okay, so my x value and my y value for this centroid is going to be pretty easy. X and y will be 1/2 base, 1/2 height. Easy enough. All right, what about a triangle? When you think about this triangle here, right? Where do we think that triangle is going to go? Now, you might just think, well, probably 1/2 base and height. And so if you thought about that, here's why it can't just be 1/2 base and height. If I go over 1/2 of the base, let's say it was there, right? So I'm going to go up this point, somewhere on that line. And I go over 1/2 to the height. That means my centroid location is going to be on this point, on that line right there of the rectangle. But that doesn't make any sense, right? Because if I try to balance on that point, there's all this weight over here and there's 0 weight over there. That's not going to work. Okay? So it's got to be in somewhere. It's got to be in here somewhere to get that even distribution of the weight. Again, thinking about, if this was a flat triangle that you were trying to, let's say it was a little flat piece of cardboard triangle that you're trying to balance, where would you be able to balance it? Okay, so the triangle equation for triangle is going to be 1/3. Okay, 1/3 of the way from the origin. Again, think about that graph. So 1/3 of the way out and 1/3 of the way up. That is the equation. Whoops. So 1/3 of the base, 1/3 of the height, and you start from your origin. Okay, it's key that you have a set origin. Your little XY point right there, that origin, that's where you're going from. Okay. All right. Now, how about this? Whoops, I'm not there yet. Sorry. Okay. So to figure out the centroid of that, okay, it's going to be, it says 4 pi r divided by 4r divided by 3 pi to get it. So first up, let's just figure out the line of symmetry, right? It's going to be, hopefully, you know, that should kind of make sense, but our line of symmetry is like that. It should be somewhere on this line of symmetry. Does that make sense? Because we do have one line of symmetry. We know if we have a line of symmetry, we can split it and we know the centroid is on that line. We just got to know how far up from this line here, how far up from the base, right? How far up is it going to go for the y value? So the x value would just be take your base in the way it is here with the circle sitting flat. You would just take your base and divide by 2, and that gets you your first angle or your line of symmetry. Okay. But what about for your circle? So the equation is going to be that right there. So we have 4 times r divided by 3 pi. Okay. So if I was given a radius of 2 inches, so this base is not 2 inches, right? This base is 4 inches. The radius is 2. So 4 times 2 divided by 3 pi. All right. All right. Why does everybody take a second to calculate that out? What is your answer going to be? How many inches up? And then I want you to figure out how you would list it. What is the X and Y location of that centroid? I will give you a minute. All right. That's enough time. So what do we get? So 4 times 2 inches, 8 divided by 3 pi. Whoa. You should get 0.8. I would not go to 0.8. I would go to 0.85 and or at least 0.849. And all, of course, we all know that from Canvas. I wouldn't be around in 0.8. I think
Mr. Spudek.
Yeah.
So like in these questions, are we going to always have like R is going to be given in the question?
Yeah. You might have to figure that out somehow, but it depends on what they give you. But
Okay.
yeah, most of the time they give you a radius or something like that.
Okay.
Okay, so going back to that again, I went around it. Now, if I would tell you this is where somebody might make a mistake, and I would tell you this: anytime you're dividing 2 numbers on bottom, divide them both on bottom. Don't do 8. Now, if you did 8 pi, your calculator might have been able to figure it out, but I would do 4 times 2 and then divided by 3 divided by second pi. All right, if you have pi on your calculator. This is a way I would enter in anytime you have two numbers on bottom, right? Quick reminder, I'm sure we kind of did that when we had to do simple machines or something like that. We might have had that to practice, but I would not have 3 times pi because then you got to worry about parentheses and all that other junk. All right. Now, here we go. Here's where the something hits a fan. All right. This might seem intimidating, might seem scary. Okay. Don't be scared. You can handle it. But the idea is that we use these symbols sigma. Okay. So if you have some crazy shape going on, okay. So let's make it simple. What if I had like a half circle connected to a rectangle, right? Well, we could break it down. If it's a shape that is not purely a triangle, purely a rectangle, purely half circle, you can take that you can take them and break them down into smaller shapes. Okay, so I could take it, if I have a shape, I can split it up. All right. Anyways, to do the calculation, and notice how there is Z, and we're not probably going to deal with Z, but if this is X, here's X, here's Y, right? There's Z. How am I doing? Am I good? Okay, right? So Z is going out. That would be your third dimension. Okay, X, Y, Z. For all of these, the equation should not be intimidating. And you're going to have some kind of equations that are crazy looking. Don't be intimidated by it, okay? But for this here, you're just going to on top, let's just deal with the X value. If I need to get the location of the centroid in the X value, I would just get the sum of the areas times the, or get the sum of the areas. Let me try that again. The centroid location times the area in each spot, get the sum of that. All right. Then down below, just divide it by the sum of the areas. I will explain this more and we will practice this by hand. Okay. But it's not going to be as crazy as you think on how to do this. All right. Okay. So here would be kind of the idea, though, if you had something very basic, okay, divide it into simple shapes, getting your X, Y point, your origin, all that stuff, okay? Let me show you really. That seems like a lot of stuff to keep track of. Here, let's look at this, okay? If we wanted to split this into simple shapes, okay, if we wanted to divide it into 3 simple shapes, what 3 simple shapes do you see that you could use? Okay, type it in the chat and don't hit enter yet. I want everybody to do it. Okay, don't hit enter, but what are the 3 simple shapes you would use to get the centroid locations? I'll tell you to hit enter soon. Okay, now go ahead and put enter. Good. Good. Okay, good. Seeing them. Yep. Well done. Well done. Okay, so yeah. So trapezoid is not a basic shape. So I don't have an equation for you for a trapezoid. Okay. So I would be looking at splitting this into a rectangle, a square, and a triangle. Okay. Like that. So then what I would do is I would have to do the centroid location for each one. And here's where it gets a little bit tricky. Remember that the values are not just the origin for all of these is going to still be down here. Okay, let me annotate and make this really looking ugly for a second. Where's my annotate? Annotate. There we go. All right, so I can do a line. Wouldn't that be better? All right, so I have my origin looking like that. All right. And then like that. Okay, so most of you would do the right thing for the rectangle because most of you would go, okay, I know halfway of the base and up halfway of the height, and you would get the centroid for location for the rectangle right there. Everyone would do that and be proud of themselves. But then when you get to, let's not even worry about number 2, let's worry about 3. You would say, okay, I know where the centroid location is, and it's a square, so it's going to be half of the base and half of the height. So my centroid location is right there. Okay, which is right talking about the shape. But when you look at, if you have to type this in, it's not going to be, so let's say this value, I'm not even going to make numbers up. You wouldn't just say that it went from here and there, and those would be your 2 answers. You have to go all the way from the origin for the X value. Does that make sense? So you have to remember the whole piece. All right. Same with this one here. So you say, oh, it's a third of the way. So you go a third of the way here for the triangle, third of the way up for the triangle. My centroid is right there somewhere. That's great. Except the answer won't be this number and that number. Your value has to be this plus the base of the rectangle, and this plus the height of that square. Okay? All right. Let's just see if we can do something together and do the calculation. All right, so I'm going to get out of my drawings. So again, there's my XY value. You have to make that origin the whole time. All right. Boom. Okay. All right. So let's do this. Go ahead and do the calculation of the areas. So why don't we do those in your notes? Figure out the areas of these shapes and get that to go. Okay, go ahead and get those areas. Okay, so here's our areas, right? Width times height, so 3 times 6, 18. 3 times 3. Oh, we're doing this triangle first. Sorry, 1/2 base times height, so 1/2 3 times 3, which is 4.5, and 3 times 3 for the square, or 3 squared is 9. Okay, so that was easy. How about doing our next thing, our centroid locations? This will be a little more difficult for you. So go ahead and calculate the centroid locations for all 3 shapes. Don't forget that you have to be from this origin over here. So the centroid location of 2 is this whole length for X and this whole length for Y. Amazon, pause. Okay, so let's see. This is what we got, right? So we have 3 inches of the width, so that's going to be 1.5. Okay. Part 2, the distance to that location right there is going to be 4 inches because it's going to be 3 plus a third of this way is 1, right? So we got 4 inches there. All right. The next one is going to be, we got the 3 inches plus 1.5 inches because that's halfway down. Okay. So that's going to be 4.5. Whoop. There we go. All right, so there are going to be our X values, our Y values. Okay, we got what? We got 3 inches going up. We got 4 inches going up. And we got 1.5 inches going up right there. Okay, so here's what you would do. You would take each area and multiply it by these centroid locations for the X value and for the Y value. All right, so here we go. Ready? Take your areas, and I want you to fill out this chart. take your areas you calculated from your notes and fill out that chart for what we got. All right, so we got our areas, 18 inches for the first one, and X value would be 1.5, right? That is right there. So A times X would be 18 times 1.5, 27. Okay. All right, area 2, we have 4.5 inches, and location 2 was 4 inches. So we have 4.5 times 4, we get 18. Okay. 3, we got 9 inches for our area for 3, right? 3 by 3. We had the X location was 4.5. So then the A times X is 40.5. All right, let's do the same thing for Y's. All right, the areas are still the same. All right, so Y values, right? It goes up 3 inches for the first one. So 18 times 3. It goes up for the next one, 4.5 inches for the Y value, right? Or that was the Y value. The area is 4.5. Let's see here. It goes up 4 inches. My bad. So 4.5 times 4. All right. 9 inches times 1.5 inches gets 13.5. Okay. I'm guessing I'm losing some people. Hopefully you're okay with what we're doing here. I would practice writing this out. So what we did was we took the area multiplied by the centroid location. Area, centroid location, right? Multiplied them all out. So now what we do is we add them up. So A times X, add those numbers up. A times Y, add those numbers up. Okay. So then that means our location is going to be, so then we got to add up the sums of the areas too. Sorry. Okay. Amazon pause. All right. So here we go. We got all those numbers. I know I just went fast with that, but it was just adding up the sums of the areas. Okay. So now to get Y and to get the Y location of the centroid and the X location of the centroid, we just take the sums of AY and divide by the sum of A. Okay, right here. So first what we're going to do is sums of AY divided by the sums of the area. So sums of the area times Y divided by sums of the area, and that's going to be our centroid location for Y. Okay. Now, what about our sum location for X? It's going to be, again, AX, sums of AX divided by the sum of A. Okay? So that is the location for the centroid. That was not fun. We are not going to be doing a lot of stuff by hand. Okay? We might do a couple by hand just so we can figure out how to do it. Now, here's something also. This is what I'm going to show you from here. We could have done this. Make sure that's my next slide too.
Wait, Mr. Spudek.
Yeah.
So like just a general question, like since we got the answers, like we know the centroid location, but if we have to mark it like on the image, do we use like a ruler or something like that? Like
Yeah, I mean it's not something that we need to care about actually marking as much as knowing where it is.
Okay.
Okay, so but if this was a plate, okay, so if this was a plate, a piece of sheet metal that's cut out in the shape, we know where we could place our finger to balance this piece of sheet metal. Okay, now that's not why we're doing it. It's more about using this for other calculations that we're moving forward, but that is important to understand. That's what a centroid is showing us, is where we could balance something. Okay. All right. So I know that was big and painful. let me just show, oh, okay. I guess I'm not going to show that. Later on, let me go back and I'm going to clear my annotations too. I am pretty sure it must be the next slide, but soon what's going to happen is it's going to show you that you could take the same thing and also treat it as one square, right? And one triangle right here. And you can actually, when we talk about sums, you could actually just do subtraction. Get this space over here and subtract it from the area of a rectangle. Okay, and it would do the same, it would get the same exact answer. All right.